Hello friends, my name is Tunisha. I am Assistant Professor in Government Engineering College, Bharatpur. I am pursuing PhD from NIT Delhi also. I am GATE qualified and NET qualified. Basically, this series is regarding the theory of computation because theory of computation is an important subject regarding the GATE syllabus. It also contains 7 to 8 marks in our GATE syllabus. So this is a very important subject if we are regarding about the GATE syllabus. So this is a lecture 1 and module 1. Now let's start. What is theory of computation? Basically, now firstly we have to understand what is computation. Computation is like somewhat if I am giving a 2-digit, that is A, B, and asked to add these 2 digits, then there are many ways you can add these 2 digits. But if I am talking about if to a general person, he can use a calculator. And if I am giving this numerical to a computer science engineer, he will make a program for adding a 2 number, right? That means he used computer for adding these 2 numbers. So this is all about a computation. Computation means something is computed. So in the TOC, we are going to make a mathematical model which solve the problem. But if I am talking about the theory, then in this theory, every model has its own capability, like what type of language it is going to accept, what type of language is not going to accept. It also have their limitation, right? So theory of computation is basically like we are making a model, mathematical model that have their own capabilities. So the definition of a theory of computation is the study of material, mathematical representation of computing software, and their capability is called TOC, right? So before going to the deep, we are covering the basic terminology, which is further very useful in the TOC series. Like everyone heard about Dfa, everyone heard about NFA. If we are pursuing BTech, then there is this is the common terminology like Dfa, NFA. But before going to start Dfa and NFA, the basic terminology is also important. So first terminology is the symbol. Symbol is basically as we use in a general. सभी लोग जनरली सिंबल यूज करते हैं, जैसे A, B या फिर कोई भी डिजिट 0, 1, 2 और 3, right? So any digit, any symbol, anything which is present in the universe, and anything which we can do with the computer keyboard. This is all about the symbols. Okay. Now what is alphabet? Alphabet is basically a set of finite, non-empty set of symbol. Means first, what is symbol? Set of symbol is known as the alphabet. Okay. So we represent the alphabet by using a sigma sign. So if we saw somewhere like sigma equals to A, B, then we easily get to know that sigma is what about alphabet. Alphabet means it contains a set of symbol which is A, B. If I'm writing like 0, 1, that means this is the set of binary alphabet, right? Because सब जानते हैं binary का मतलब 0 और 1. Right? If I'm going to write like 0, 1 up to 9, then this is decimal alphabet. Simple. Binary means 0 or 1, decimal means 0 to 9. So alphabet is what? Set of symbol. यहाँ पे एक बहुत अजीब टर्म है, that is non-empty. Non-empty का means there is nothing like null. Non-empty मतलब वो खाली नहीं है, उसमें कुछ ना कुछ है. Either it is alphabetical, either it is binary, either it is decimal. Okay. Now the next terminology. नेक्स्ट टर्मिनोलॉजी इज स्ट्रिंग. स्ट्रिंग क्या होता है? इट इज एनी सीक्वेंस ऑफ 0 or more symbol over given alphabet. Suppose I will give you an example, like if I write sigma equals to a comma b, तो इसमें स्ट्रिंग क्या होंगे? स्ट्रिंग बेसिकली पहली स्टेटमेंट क्या है? इट इज एनी सीक्वेंस. सीक्वेंस मीन्स सीक्वेंस कुछ भी हो सकता है. तो पहला सीक्वेंस क्या है? या तो वो 0 होगा या उसमें मोर सिंबल्स हो सकते हैं. तो पहला द फर्स्ट सीक्वेंस इज लाइक नल. एनी कॉम्बिनेशन ऑफ ए एंड बी, like simple A, simple B, A, B, AB, and BA, up to infinite. Like there are infinite number of sequences present over an alphabet A and B. If I'm writing like 0, 1, the string can be a null or 0 or 1 or 0, 1, 1, 0, 1, 1 and 0, 1, right? So what is a string? A string is basically a sequence of 0 or more symbols over an given alphabet. Means आपको ये alphabet given होगा. Now तो आपको पूछा जाएगा कि इसकी strings क्या होंगी. Okay class? Now moves to the next sub terminology of string is length of string. Suppose I am writing a string as W. This is A, B, B. Now I'm going to ask you about the length of W. So the length is represented by the module sign, and the length should be like 1, 2, 3. Means you have to count a single symbol in a given string. This is the length. If I'm writing like A equals to AB, AB, then what is the length of W? Length is 4. Okay. Now the next terminology is substring. Substring of a given string. Substring basically, as a name says, substring मतलब string given है, आप उसकी substrings पता करनी है. ओके, तो substring का मतलब हो गया कि उसका एक पार्ट. सपोज मैं कहूँ 0 length string is like null because there is no single alphabet. If I am giving 1 length, then 1 length is equals to 0, 1, right? 2 length is like 0, 0, 1, 0, 1, 1 or 0, 1, right? अगर मैं बोलूं कि मुझे 2 लेंथ की सब स्ट्रिंग्स पता करनी है, तो सब स्ट्रिंग कुछ भी हो सकती है. 0, 0 भी हो सकती है, 0, 1 भी हो सकती है, 1, 0 भी हो सकती है, 1, 1 भी हो सकती है. मतलब इसमें से अगर कुछ भी आ रहा है तो वो सब स्ट्रिंग होगा लेंथ 2 का, राइट? ऐसे हम और भी लिख सकते हैं. वी कैन राइट दिस इन अ फर्दर वे लाइक 3 लेंथ, 4 लेंथ, 5 लेंथ. सो दिस इज ऑल अबाउट द सब स्ट्रिंग. सब स्ट्रिंग मीन्स इट इज द पार्ट ऑफ अ गिवन स्ट्रिंग, right? Now the next terminology is prefix. The next terminology is prefix. Prefix means as a name pre. Pre means कोई भी चीज पहले आ रही है. जैसे मैंने आपको एक string given है, then we have to calculate the prefix of a string. Prefix of a string means either it should contain null or a pre A, AB and ABB. This is the prefix of ABB. Similar way, if I'm taking another example like BBA and ask about the prefix, then prefix should be like null, V, BB and BBA. Now, prefix means we should start from the first letter, pre, right? First cover the single one, then combine it with the another second letter, then combine with another third letter. This is all about the prefix. Now the suffix. The next term is suffix. Suffix like if I am writing a string like A, B, B, then suffix should be null. Suffix means we start from the last symbol. That is B, then B, B, then B, A, B, B. This is the suffix. Okay. अब आप सोच रहे होंगे कि हम ये बेसिक टर्मिनोलॉजी क्यों पढ़ रहे हैं, क्योंकि गेट में तो ये नहीं पूछा जाता, राइट. बट अगर हमें डीएफए और एनएफए को पढ़ना है तो उसके पहले हमें ये पता होना चाहिए कि स्ट्रिंग को लेंथ क्या होती है, स्ट्रिंग के हम प्रीफिक्स कैसे लिख सकते हैं, स्ट्रिंग का सफिक्स कैसे लिख सकते हैं, सब स्ट्रिंग्स क्या होती हैं, राइट. So this is basically for fresh up your mind about that what is the basic terminology which we are going to use for the further lecture. Okay, so this is all about this string. Now I'm giving you an exam and I'm giving you a question. Now you have to tell me what is the length, what is suffix, what is prefix of that given question, right? So your question is W equals to A, B, A, B, A. What is length? 1, 2, 3, 4, 5. What is substring of length? 3. Substrings of length 3. What is possible substrings of length 3? That should be like A, B, A, or A, B, B means any combination of A and B which have length 3, right? What is prefix? Prefix like null, A, A, B, A, B, A, A, B, A, B, A, B, A, B, A, right? What is suffix? Null, A, B, A, A, B, A, B, A, B, A, and A, B, A, B, A. Okay, clear? What is length, what is prefix, and what is suffix? Now, move to the next terminology. This is power and alphabet. Power and alphabet is also important. Like what is alphabet? Alphabet is sigma. Like suppose A, 0. Now what is power of alphabet? If I am going to write a 0 as a superscript of a sigma, then this is a 0 length string. Means it contains 0 length string, that is null. Now if I am writing sigma 1, then it contains a length 1 string. Sigma 2, it contains length 2 string. Okay. If I am writing sigma 3, then it contains 3 length string. Sigma 4 contains 4 length string, right? Now what is knee star closer? Knee star closer means we put a star as a superscript of a sigma, which means it is the combination of 0, 1, union of 2 up to the possible strings. Okay, what is positive closure? Positive closure means we put a plus sign over a sigma. That means sigma star minus null. Positive closure में कभी भी null string नहीं आती है. This thing you have to be remember. The positive closure does not contain any null string. It starts from sigma 1 union sigma 2 union sigma 3 up to end. Now what is the meaning of if I am writing like sigma equals to 0, 1 star? Could someone tell me? This is all about कि 0 और 1 की जितनी भी possible strings होंगी we can cover in sigma star. Like what is small string? That is null. 0, 1, 1, 1, 1, 0, 0, 1 and 0, 0, 0, 0. Means इसमें जितनी भी possible strings हो सकती हैं 0 1 को लेके, हम सारी लिखते हैं सिग्मा स्टार में, ठीक है। अगर मैं बोलूं सिग्मा पॉजिटिव मीन्स नल को छोड़ के ये 0 और 1 से स्टार्ट होता है, ओके। तो दिस इज एन पॉजिटिव क्लोजर. Now the main thing, most important thing of theory of computation is the three term. The three term like LGA. सबको याद रखना है LGA. L for language, G for grammar, and A for automata. Okay, simple है LGA, कैसे भी आप रख सकते हैं. L for language, G for grammar, A for automata. Now, what is language? ठीक है, हम सब कोई ना कोई लैंग्वेज बोलते हैं, जैसे हिंदी, इंग्लिश, है ना. ऐसे ही कंप्यूटर भी कोई ना कोई लैंग्वेज समझता है, ठीक है. तो अगर हम लैंग्वेज की बात करें पीओसी के व्यू में, देन द लैंग्वेज इज अ सेट ऑफ स्ट्रिंग over the given alphabet. ठीक है, this is set of string over an given alphabet. Suppose I am giving an alphabet like sigma equals to A comma B. Then language can be anything. Like if I am giving the equal number of A and equal number of B. So language should be like n की power A की power n, B की power n, because n is greater than 0. If I am writing this, अगर मैं इंग्लिश में बोलूं, that is I want equal number of A and equal number of B. But what the computer understand, it's simply like this. L equals to A to power n and B to power n, and n is greater than 0. Okay. Now, language can be a finite or infinite. Finite and infinite. Now tell me, what is this language? Is it finite or infinite? Everyone knows it. N is greater than 0. Means there can be a n equals to 1, n equals to 2, up to infinite. So this language is infinite. If I am giving a language like A की power n, B की power n, and n is less than 10, is this finite or infinite? कोई बता सकते हैं? Simple. The n is less than 10. That means there is a combination like 0, 1 up to 9. So this is finite. Okay. So this is finite. We can finite means the limitation we previously knows, and infinite means the limit and we doesn't know. Okay. So what is grammar? The next term is grammar. The next term is grammar. Grammar basically have 4 tuples. Okay, 4 tuples means G equals to B, T, P, and F. Okay, B is like set of non-terminal. Okay, T is like set of terminal. P is somewhat set of reduction rule, and L S is start symbol. Okay. V is what? Set of non-terminal. T is what? Set of terminal. P is what? Set of production rule. And S is what? Start symbol. Okay. So before going to types of grammar, we have to learn something like how we write a grammar. We can write a grammar in a form of X tends to Y. X can be anything, Y can be anything. Okay. This is simply we can represent something as X and something as Y. So representation of grammar is some like X tends to Y. Okay. Now what is set of non-terminal? Right? Set of non-terminal and set of terminals. Set of non-terminals means a capital letter A, B, C. Anything written on as a capital letter we can consider as a set of non-terminal. Now what is set of? This is not directly tends to set of terminal. Set of terminal like small letter A, B, C, any digit, or it can also contain null. Except from a capital letter, everything is a terminal. Okay. So non-terminal means a capital letter. Terminals means except from capital letter. Okay. So this is the way by which we can write a grammar as a X tends to Y. X can be anything, either a terminal, or a non-terminal, or a combination of terminal and non-terminal. Similar way as Y, either it is a combination of terminal, non-terminal, or simply it is terminal and non-terminal. Okay. Now going to further. अब हमने क्या सीख लिया? सिंबल क्या होता है, अल्फाबेट्स क्या होते हैं, स्टार क्लोजर क्या होता है, पॉजिटिव क्लोजर क्या होता है. ठीक है. लैंग्वेज कैसे लिखते हैं और ग्रामर क्या होती है. अब हम आगे बढ़ते हैं. द ग्रामर इज देयर आर सम टाइप्स ऑफ ग्रामर which is like first grammar is regular. Regular grammar is something like we can write it in a two way, either in a left linear way or right linear. Okay, left linear means something which is grow from the left hand side. Like suppose there is a rule, as we can write it as T star and T star. This is the way by which we can write a left linear, and this is the way by which we can write a right linear as this is a standard format. Means on the left hand side there is a non-terminal. On the right hand side there is a combination of, firstly the non-terminal has to come, then the terminal, any combination of terminal. Similar way in the right, the left side is non-terminal, the right hand side is like firstly any combination of terminal, then it is followed to any combination of non-terminal. I will give you some example. S tends to S, small a and A. We can also write it like S tends to A, S and A. If I am giving a numerical, like I want a string as AAA from the given grammar. So how can we write AAA from given grammar? Everyone knows we have to construct a tree. So the root is the left hand side from the first production rule, that is S. Now S can be replaced by either SA or A. S can be replaced by either AA or A. Firstly, what we want? Triple A. That means A and A. Right? Again S replaced by SA and again replaced by A. So as you see, the tree is grow from the left side. Like always we have replaced left side. ये सबको पता है कि हमेशा नॉन टर्मिनल ही रिप्लेस होता है, टर्मिनल कभी भी रिप्लेस नहीं होता है. टर्मिनल मीन्स टर्मिनेट हो चुका है, नॉन टर्मिनल मीन्स अभी ये टर्मिनेट नहीं हुआ है. जब तक नॉन टर्मिनल की जगह पे एक टर्मिनल नहीं आ जाता तब तक वो कंप्लीट नहीं होता है, जब तक वो टर्मिनेट नहीं हो सकता है. So as we know that the trees grow from the left hand side, so this is the left linear grammar. If I'm talking about the right linear grammar is opposite from the left linear grammar because it grows from the right hand side. Right? It grows from the right hand side. So this is a right linear grammar. It grows from the left hand side. So this is a left linear grammar. Regular grammar can be represented in two ways, either as a left linear or a right linear. Left linear means पहले नॉन टर्मिनल आएगा फिर टर्मिनल आएगा. राइट लिनियर मीन्स पहले टर्मिनल आएगा फिर नॉन टर्मिनल आएगा. ओके, so this is the first type of grammar which is regular. Now the second type is context free grammar. The second type is context free grammar. Context free grammar is basically have there some restriction, like how to write x tends to y in a context free grammar. CFG, that is context free grammar. Context free grammar we can write as V. Here V is the combination of V union T star. Like I will give you some example as S tends to A, S, B and null. S tends to B, A tends to small a, small b, capital A, then A, B tends to A, B and null. Right? So this is the form of CFG. In the regular grammar, there is rule B tends to only B T star or T star, or B tends to T star B T star, right? But in the CFG, the right hand side is the combination of terminal and non-terminal. यहाँ पे कुछ भी आ सकता है, टर्मिनल और नॉन टर्मिनल का कॉम्बिनेशन. रेगुलर लैंग्वेज में पहले टर्मिनल आना चाहिए या पहले नॉन टर्मिनल आना चाहिए, बट CFG इज द कॉम्बिनेशन ऑफ, इन द राइट हैंड साइड इज द कॉम्बिनेशन ऑफ एनी टर्मिनल एंड नॉन टर्मिनल. नाउ एक टर्म थी ग्रामर में, प्रोडक्शन रूल. प्रोडक्शन रूल क्या होता है? द वे विच वी कैन राइट अ ग्रामर इज नोन एज प्रोडक्शन रूल. ओके, टर्मिनल नॉन टर्मिनल सबको पता है. And the root of a tree, from where we start to make a tree, this is known as start symbol. Means if you are going to write a grammar, it contains 4 tuples, set of terminal, set of non-terminal, production rule and the start symbol. If you have these 4 tuples, then your grammar should be maybe right. Okay. Now the next type is context sensitive grammar. Okay, the short form is CSG, context sensitive grammar. Context sensitive grammar have their own limitation, like the length of left hand side is always less than or equal to the length of right hand side, and where X is the combination of any terminal and non-terminal, as X belongs to any terminal and non-terminal, or Y belongs to any terminal and non-terminal, right? But X may contain at least one symbol. Okay, class? Means suppose I'm writing example as tends to A, small a, capital A, B, and A, and A tends to C, D. हमने पीछे जो भी रेगुलर लैंग्वेज और कॉन्टेक्स्ट फ्री ग्रामर देखी थी, उसमें कभी भी लेफ्ट हैंड साइड पे हमारी दो कॉम्बिनेशन नहीं आते थे. तो कॉन्टेक्स्ट सेंसिटिव ग्रामर इज वेरी डिफरेंट फ्रॉम कॉन्टेक्स्ट फ्री ग्रामर एंड रेगुलर ग्रामर. Like we can easily identify that this is a context sensitive, because in the context sensitive grammar the left hand side should be a combination of terminal and non-terminal. Okay, so the length of left hand side is 2, the length of right hand side is 2 is less than equals to 2, then this is a context sensitive grammar. Okay, next one is the recursive enumerable grammar. Recursive enumerable grammar. Recursive, this is the fourth type, and this was the third type. Recursive enumerable grammar. REG. Okay, recursive enumerable grammar is restricted as like x tends to y, where x where x belongs to x and t. Same as context sensitive grammar, y belongs to any combination of non-terminal and terminal. But there is nothing condition like left hand side length is less than equals to the right hand side. So it can be like example as tends to small a, capital A, B, then B as, then A and B. This is REG. Okay, class. This is REG. Means only the restriction is like left hand side and right hand side is the combination of terminal and non-terminal, but there is nothing something like and length of left hand side is less than equals to the length of right hand side. So this is known as the recursive enumerable grammar. अब आप सोचोगे कि मैम ये ग्रामर क्यों पढ़ा रहे हैं. ग्रामर का बेसिकली मतलब है, जैसे मैंने आपको बोला था स्टार्टिंग में कि आई वांट अ मैथमेटिकल मॉडल which going to accept string as which and with b. Then you have to create a mathematical model by using some language. For language you need some grammar. So firstly you have to understand what is language, what is grammar, then you are able to make a mathematical model. Okay, class? Now the most important term is automation. Automation is very important because theory of computation another name which is known as the automata, right? So automation is basically like something there's a box, here's something written, or we can say this is the mathematical model. We give some input and we have some output. Output can be anything. First it can act as a scepter. ये कुछ हम देते हैं और ये एक्सेप्ट करके बताता है कि ये एक्सेप्ट कर रहा है या नहीं कर रहा. Okay, so it can be act as a acceptor, means it give the output as yes or no. Okay, we give some input. अब ये वर्क कैसे करता है, right? We have a simple string as W which is A, B, D, and we have a task to make a mathematical model which going to accept a language which is end with V, right? means this automata is all about a mathematical model, which means in which the a string which is going to end with v, it is going to accept. Okay, now test. Now we are going to test. So we just put a string as a, b, b. So this is end with v. So the result should be is. Okay. When we pass this input string to the automata, it says that w belongs to L. L means language. Language means the thing which is end with B. Okay. So it gives the output as yes. If it is not end with B, suppose I am giving some another example as A, B, A, then the answer should be W does not belongs to L. So this is no. Okay. So first work of our automata is it can be work as a acceptor. The second work of automata is like the generator. Okay. Generator should be like there is some mathematical model. We give the same input and it produces some output. Okay. Suppose I am giving an example. I want a mathematical model which is going to accept the ones complement, which is going to produce a ones complement. That is one. Suppose I am giving 101 as the input, then the output should be like 010, the ones complement of string. We can also make as a twos complement or another mathematical model from where we want some output. So automata दो तरीके से काम करता है, एक एक्सेप्टर की तरह और एक जनरेटर की तरह. ठीक है. नाउ टाइप्स ऑफ ऑटोमेटा. जैसे टाइप्स ऑफ ग्रामर थे वैसे ही टाइप्स ऑफ ऑटोमेटा है. इसको हम जल्दी कवर करते हैं. पहला टाइप है इसका फाइनाइट ऑटोमेटा. ओके. फाइनाइट ऑटोमेटा जो रेगुलर लैंग्वेज को एक्सेप्ट करता है. रेगुलर लैंग्वेज को, रेगुलर लैंग्वेज में जो रेगुलर ग्रामर के थ्रू जनरेट होती है, दैट इज नोन एज रेगुलर लैंग्वेज. फाइनाइट ऑटोमेटा कैन बी अ टू टाइप, दैट इज DFA एंड NFA. DFA means D for deterministic, मतलब जिसको हम डिटरमाइन कर सकते हैं. N is for नॉन डिटर्मिनिस्टिक, जिसको हम डिटरमाइन नहीं कर सकते. राइट. सेकेंड इज PDA, दैट इज नोन एज पुश डाउन ऑटोमेटा. ये किस लैंग्वेज को एक्सेप्ट करेगा? ऑब्वियसली CFG. It also have two types, that is NPDA and DPDA. D is for deterministic and N is for non-deterministic. Okay. The another type of automata is third type is LBA, linear bounded automata. ये किस लैंग्वेज को एक्सेप्ट करेगा? CSG. सबको पता है, पहले हमने पढ़ी थी रेगुलर, तो वो FA को करता है. फिर हमने पढ़ा था CFG, वो PDA को करता है. और जो हमने थर्ड टाइप पढ़ी थी CSG, वो LBA करता है उसको एक्सेप्ट. मैंने आपको स्टार्टिंग में ही बताया था कि हर मॉडल की एक लिमिटेशन होती है. मींस जैसे FA केवल रेगुलर लैंग्वेज को कर सकता है, PDA केवल CFG को कर सकता है, LBA केवल CSG को कर सकता है. ठीक है. तो ये इनकी लिमिटेशंस भी हैं और टाइप्स भी हैं. ओके. नेक्स्ट फोर्थ टाइप इज ट्यूरिंग मशीन, TM, दैट इज ट्यूरिंग मशीन. ठीक है. ट्यूरिंग मशीन. लास्ट टाइप हमारा कौन सा बचा है? REG, रिकर्सिव इन्यूमरेबल लैंग्वेज, और वी कैन से रिकर्सिव इन्यूमरेबल ग्रामर. So Turing machine also have two types, that is DTM and NTM. D for deterministic and for non-deterministic. Okay, so there are 4 types of grammar, as same with there are 4 types of automation, one automation for each. Now the most important topic which is always asked in gate questions, what is the Chomsky hierarchy, or we can say the hierarchy of automata and the grammar. So this is very important regarding the gate syllabus, तो please ध्यान से पढ़िए. Okay, up the middle one, the smallest circle is going to represent by type 3, then same is type 2, then type 1, then type 0. Type 3 means regular, type 2 means CFG, type 1 means CSG, type 0 means REG. Okay, means type 3 is the subset of proper subset of type 2, is the proper subset of type 1, is the proper subset of type 0. Means regular is the subset of CFL, is the subset of CSL, is the proper subset of. Means if I'm saying that this is a regular grammar, then it can be a CFG, it is also CSG, and it is also REG. But if I'm saying that this is a REG, then this is not possibility that it is also a regular grammar, it is also CFG, it is also CSG. Means because रेगुलर ग्रामर सबसे छोटी है, इसलिए जो भी रेगुलर होगी वो CFG भी होगी, CSG भी होगी और रिकर्सिव एन्यूमरेबल भी होगी. बट इफ द लैंग्वेज इज ओनली CSG, तो हम नहीं बोल सकते दैट इट कैन बी अ रेगुलर ग्रामर. सो दिस इज द चोमेस्की हायरार्की. चोमेस्की एक साइंटिस्ट थे, उन्होंने इसको हायरार्की दी थी कि कौन सा मॉडल कहाँ फिट होता है. ठीक है, नेक्स्ट वन, एक्सप्रेसिव पावर ऑफ ऑटोमेटा. इस पे काफी क्वेश्चंस आ चुके हैं. एक्सप्रेसिव पावर का मीन्स होता है कि कौन बड़ा है और कौन छोटा है. पावर हमें बेसिकली वही है कि कौन बड़ा आ गया और कौन छोटा आ गया. एक्सप्रेसिव पावर का मतलब होता है, मैंने जैसे हमारे चोमेस्की में हमें पता चला कि रेगुलर सबसे छोटे है, तो एक्सप्रेसिव पावर का मतलब हो गया FA, then FA is less than DPDA, then less than PDA, then less than LBA, then less than Turing machine. ठीक है, अब जो हमने 2 टाइप पढ़े थे, जैसे लाइक DPDA एंड NPDA, NFA एंड DFA, DTM एंड NDTM. तो DFA is always equivalent to NFA. Okay, DPDA is not equivalent to NPDA. DTM is equivalent to NTM. ठीक है क्लास, DFA is equivalent to NFA, DPDA is not equivalent to NPDA, DTM is equivalent to NTM. Same with the power, DPDA is less than powerful than NPDA. Okay, मतलब FA सबसे छोटा, फिर कुछ ऐड हुआ DPDA में, फिर कुछ ऐड हुआ NPDA में, फिर कुछ ऐड हुआ LBA में, और फिर कुछ ऐड हुआ ट्यूरिंग मशीन में. ठीक है, इफ आई एम सेइंग कि मुझे ट्यूरिंग मशीन डिजाइन करनी है बाय यूजिंग PDA एंड बाय यूजिंग FA, तो अगर PDA with plus 1 stack is equivalent to TM, और FA plus 2 stack is equivalent to TM. Okay, PDA equals to FA plus 1 stack. अब ये स्टैक क्या होता है, फाइनाइट ऑटोमेटा क्या होता है, ये हम आगे डिटेल में पढ़ेंगे. But for now, आप ये समझ लीजिए कि Turing machine can be designed by using PDA, but with one extra stack, FA with extra 2 stack. These question was already asked in GATE syllabus कि हम Turing machine को FA से कैसे डिजाइन कर सकते हैं, PDA को FA से कैसे डिजाइन कर सकते हैं. Okay, class. So this is all about basic terminology, like what is alphabet, what is symbol, what is string, what is knee closer, what is first. Main topic of the today's session, that is FA. This is finite automata. Okay, finite automata is also known as finite state machine. Okay, that is FSM. Finite automata is two types. Finite automata are two types. First is finite acceptor, and next is finite transducer or finite generator. Okay, that means FA without output, and this is FA with output. Okay, so it has two types. One is DFA and other one is NFA. It has two types. One is Moore machine. Next is Millie machine. Means Moore machine and Millie machine, something like which have an output. Finite automata like DFA and NFA, which doesn't have any output. It just gives that this string is accepted by that language or not. Okay. Moore machine में, Millie machine में हमारा output होता है. DFA, NFA में हमारा output नहीं होता. Okay, class. Now the topic is model of finite automata. Basically, NFA and DFA is the GATE syllabus. Moore and Millie machine are not included in GATE syllabus. So if you want, then I can make another video for Moore and Millie machine. But now in this series, I am only covering DFA and NFA. Okay. Now, what is the basic model of finite automata? This is something as input tape. This is known as input tape. There's something like finite control. Or there's something head. It moves from left to right. कुछ इनपुट टेप होता है, एक कुछ रीड हेड होता है, and there's something finite control. Okay, suppose I'm taking an example as I have to make a model in which the string should be start from A. The string should be start from A. That means the string can be A, B. The string is like A. The string is like A, B, B, E, E. Okay. So suppose so how we can check the given string is according to our mathematical model or not? So first the method is we have to put that we have to take the input string in an input buffer as is A, B, B, B. Input the read head start from the starting symbol, then it moves from A, then it moves to B. In the next second, it moves to B and it moves to B. If what we have checked in the finite control that it should be start from A. If it is start from A, then it doesn't matter what it going to be end. either it's going to be end by A, either it's going to be end by B, it doesn't matter. ठीक है, जनरल लैंग्वेज में बात करें, हम एक स्ट्रिंग लेते हैं, स्ट्रिंग को इनपुट बफर में डालते हैं, रीड हेड केवल रीड करता है, रीड करने के बाद ये केवल स्टार्टिंग से पॉइंट करता है और एंड तक जाता है. Now this finite control is basically like a mathematical model which has to accept the string which is start from A. तो ये A को चेक करता है स्टार्टिंग में, अगर स्टार्टिंग में A मिल रहा है तो उसे कोई फर्क नहीं पड़ता एंड किससे हो रहा है, ये केवल A चेक करता है और इस स्ट्रिंग को एक्सेप्ट आउटपुट पे ले आता है. ओके, तो दिस इज द मॉडल ऑफ फाइनाइट ऑटोमेटा. कि इसमें क्या क्या होता है. तो फाइनाइट ऑटोमेटा में what finite automata contain? It is input tape. Second one is the read head or something like finite control. And the most important thing, input tape read from left to the right. Okay. Okay class. So next is representation of finite automata. Finite automata can be represented in a 5 tuples, that is Q, sigma, then Q naught and F. Okay, this is going to represent set of finite state. This is, as we all know, what is this? This is input alphabet. This is transition function. Transition function is basically like it is defined over a transition of FA for state and input. Okay, this is your start state which belongs to finite state, means which belongs to capital Q. Q naught is the start state which is belongs from finite state. This is your final state. It also belongs to set of finite states. Okay, this is the final state which also belongs to set of finite state. And this is Q naught as a start symbol. Okay, so finite automata can be represented by a 5 tuples. One is finite state, another is input alphabet, next one is transition function, other one is start state and final state. Start state and final state belongs to capital Q. Input alphabet is given by the user. And transition function means we have to make something, we have to give some transition by which the model is going to be controlled. Okay. So state transition diagram. Finite automata can be represented in a 2 ways. First way is state transition diagram. In the state transition diagram, like something, suppose I am giving state transition diagram have their own rule. First way, state represent by circle. Okay, and transition given by arrow sign. Okay, suppose I am taking an example as Q naught this is something like we have to accept the language like a की power n. Okay, a की power n, inputs alphabet is only a, and we have made to a model which accept the a की power n is greater than 0. Okay, we also make it by single state, but for I just make it by 2 states just because to understand what is the initial state and what is the final state. or though state can be represented by circles. This is the initial state. We can represent this initial state by putting a single arrow to direct it that circle. Okay. This is the final state. Final state means there's two circles around a state number. We can take any state like Q naught. We can take any symbol as Q naught, or either I can take A, capital B, capital C. It's just a naming, like by which we can differentiate that this is the initial state, this is the final state. Suppose there's a transition, there's some between state as A, then A. This is Q2. This is an intermediate state. Okay. Basically, what we are doing, we are just suppose there's a question like we have to make a mathematical model in which the string should start from A and end with and also with A, and there's a input alphabet only A. So we have to make some transition. Like transition basically define the flow from initial state to the final state, right? So the one-way representation of mathematical model is state transition diagram. Means कि हम एक डायग्राम बना सकते हैं जो हमारे फ्लो को डिफाइन करेगा, right? Another way to make to define a finite automata is the transition table. Transition table basically we have to make a transition table. एक टेबल बनानी है, ठीक है. टेबल में क्या करना है, यहाँ पे हमें जो अल्फाबेट गिवन है उनको लिखना है, अल्फाबेट जो गिवन है, ठीक है. यहाँ पे जो हमारी स्टेट्स हमारे डायग्राम में आई है उनको लिखना है, ठीक है. इनिशियल स्टेट को इनिशियल की तरह लिखना है. फाइनल स्टेट को आइदर आप सिंगल सर्कल से लिख सकते हैं एंड ऑल्सो यू कैन रिप्रेजेंट बाय स्टार, ठीक है. इनिशियल स्टेट में हमें क्या करना है, सपोज दिस इज डायग्राम A, Q1 and this is A. So this so we can take only A here because the input alpha is only A. So Q naught पे A देने पे हम कहाँ जा रहे हैं, Q1 पे. Q naught पे A देने पे हम कहाँ जा रहे हैं, Q1 पे. Q1 पे A देने पे हम कहाँ जा रहे हैं, Q1 पे. This is the way we can represent the state transition diagram. Like from if we are at the state of Q1, Q naught, then if I am giving a transition like A, then from Q naught where I am going, this is what we have written here. Okay. The main important thing to design a finite automata is either you can represent it by a diagram or you can represent it by a table. Okay. So these are the two ways by which you can represent a finite automata. Now the next topic is Dfa. The most important topic is Dfa. Dfa means Deterministic Finite Automata. Okay. In the deterministic finite automata, as I have told you that all that the finite automata has 5 tuples. So same with the Dfa, it also have a 5 tuples. Dfa is what Q, sigma, condition, Q naught and F. Now capital Q क्या था, सबको पता है, finite state. Sigma, input alphabet. This is the transition function. Transition function means it maps sigma to Q tends to Q. Means एक स्टेट पे हम कोई भी इनपुट अल्फाबेट दें तो हमें एक स्टेट ही मिलती है, ठीक है। वो स्टेट कुछ भी हो सकती है. दिस इज ऑल अबाउट द ट्रांजिशन फंक्शन. You know very well this is start symbol, or we can say initial state. This is your final state. आया समझ में भाई? ये तो क्या हो गया स्टेट का ग्रुप, ये क्या हो गया इनपुट अल्फाबेट का, ये हो गया ट्रांजिशन. ट्रांजिशन का मतलब हो गया किसी भी स्टेट पे कोई भी इनपुट देंगे हमें एक स्टेट मिलेगी. ये हो गया हमारा इनिशियल स्टेट और ये हो गया हमारी फाइनल स्टेट. ठीक है, बस यही है डीएफए. देखो मैं आपको थ्योरी नहीं करा रही हूँ, मैं आपको टेक्निक्स बता रही हूँ, क्योंकि गेट के सिलेबस में टेक्निक्स आएंगी तो आपको पता होना चाहिए डीएफए का ट्रांजिशन फंक्शन क्या है, क्योंकि एनएफए का जो ट्रांजिशन फंक्शन है वो इससे डिफर है. ठीक है. नाउ अब हम कैसे डिजाइन करते हैं डीएफए, ये कुछ क्वेश्चंस हैं जो आपको प्रैक्टिस के लिए मैं बता रही हूँ कि डीएफए कैसे डिजाइन करते हैं. तो आप पहले क्वेश्चन रीड करते हैं. कंस्ट्रक्टर डीएफए दैट एक्सेप्ट अ लैंग्वेज वेयर इट कंटेन ऑल बाइनरी स्ट्रिंग. बाइनरी स्ट्रिंग जैसे आई आपके दिमाग में आ जाना चाहिए कि इनपुट अल्फाबेट हमारे क्या होने हैं 0,1. याद है मैंने फर्स्ट लेक्चर में बताया था बाइनरी स्ट्रिंग मीन्स 0 and 1. अब हमारे इनपुट अल्फाबेट हमें समझ में आ गए. अब उसने बोला है कि एक हमें ऐसा डीएफए बनाना है that accept a language where it contain all binary strings. All binary strings का मतलब हो गया कि 0,1 star, right? That means it contain null, it also contain 0, it also contain 1, it also contain 0, 0, 1, 0 and many more. Means the DFA should accept null string as well as 0, as well as 1, as well as 0, 0, as well as 1, 1. So we start. We take our initial state. Now there is a trick like how the null state is going to represent. If I'm making an initial state as a final state, that itself means that it accept null string. मीन्स मैंने कुछ भी नहीं दिया फिर भी ये फाइनल स्टेट पे पहुंच रहा है, तो इसका मतलब हो गया कि ये नल स्ट्रिंग को भी एक्सेप्ट कर रहा है. ओके. नाउ द नेक्स्ट इज 0. मीन्स 0 देने पे भी मैं फाइनल स्टेट पे आनी चाहिए, राइट. फिर नेक्स्ट इज 1. मीन्स अगर मैं इस पे 1 भी दूं तो भी मैं फाइनल स्टेट पे आनी चाहिए. ठीक है. नेक्स्ट इज 0,0. अगर मैं 0 दूं फिर 0 दूं तो भी मैं फाइनल स्टेट पे होंगी, राइट. अगर मैं फिर से 1 दूं फिर से 1 दूं फाइनल स्टेट पे होंगे. नाउ जनरेट अ रैंडम स्ट्रिंग टू चेक दैट द डीएफए you have made it is it correct or not. Take random string as 0, 1, 0, 1, 0, 1. Now check from initial state Q0. When I'm giving 0, then I'm also in the Q0. Then Q0, if I'm giving 1, then I'm on Q0 state, then again 0, then Q0, and finally I'm going in Q0. And Q0 is your final state as well as your initial state. तो हमने इनिशियल से स्टार्ट किया और हम फाइनल पे पहुंच गए. दैट मीन्स ये एक्सेप्ट हो रही है और ये ही आपकी कोई भी बाइनरी स्ट्रिंग्स हो सकती है. ठीक है. तो ये गया आपका डीएफए आपके क्वेश्चंस के अकॉर्डिंग. नाउ नेक्स्ट इज कंस्ट्रक्ट अ डीएफए दैट एक्सेप्ट अ लैंग्वेज और इनपुट अल्फाबेट A, B which end with B. Like what? Which end with B. The condition is that end with B. That means the input alphabet is A, B, and the condition is end with B. Means it should be end with B. Means it should be like B or AB or ABB. Means something which is end with B. Okay. So start. Make an initial state as a Q0. The first one length string which I have to make, for which I have to take a transition as B. After giving B, I reach to final state. Now suppose I'm giving final state name as a Q1. Okay. Now the second two-length string possible is A, B. Means at the Q naught, I have to make something like A so that I can reach a final state after giving A, B, right? This is A, B. Two length, if there is there any two length string possible? Yes, this is like B. B also possible as a two length string. So if I'm giving 2B, like first at the first B I reach Q naught, Q1 and Q naught, if I'm giving B, then I also have on the state as Q1. ठीक है, अब हमें ठीक लग रहा है ये, हाँ कुछ तो चल रहा है, बट ये वही चल रहा है जो हमने बनाया है कि ये एंड हो रहा है आपके B के साथ. But there also one possibility, like the thing which you have in your mind at the time of drawing a DFA, that for each state you have to maintain all input alphabets. Like for Q naught you have to make a transition for A and B, and same with Q1 you also have to make a transition for A and B both, right? But now if I'm seeing that only then for the Q1 I have only designed a transition for B. What about A? So we have to make one another transition for A. Suppose if I am giving A as a Q1, suppose, then it can be is it possible that it can accept a string like A, B, A, right? Is it follow our condition? No. So for A, so this is not the right transition for A at Q1, right? Suppose I am giving a transition as A. Is it follow our condition that it should end with B? Yes. Right? So now for checking our DFA, I am just taking a random string A, B, A, B, A. Okay. This is my way to check our DFA. Everyone has its own way to check the DFA, but this is the simple way to check that your DFA is perfect or not. Right? So check at Q1, if I'm giving A, then I reach Q naught. If at Q I reach Q1, then at Q1 I reach Q naught, like A, B, A, B, A, and A, right? Because it is end with A, so this is not accepted. At last I am on Q naught, right? So this is your right. Okay. Now I have also taken two more examples to deeply understand what is DFA and how to construct that DFA. So now construct a DFA that accepts a language of input alphabet that have a substring as AB. Substring आ गया जो हमने B series में पढ़ा था. That have a substring AB, right? Now input alphabet is sigma A, B. सबस्ट्रिंग ए बी का मतलब हो गया ए बी एक्सेप्ट हो सकता है, ए बी एंड बी. मीन्स दिस पोजिशन इज फिक्स्ड. लेफ्ट हैंड साइड देयर मे बी अ ए और बी, राइट हैंड साइड देयर मे बी अ ए और बी, और एनी कॉम्बिनेशन ऑफ ए एंड बी पॉसिबल. बट द पोजिशन ऑफ ए बी इज फिक्स्ड, कि उसमें ए बी आना चाहिए. अब उसके लेफ्ट साइड पे कुछ भी आ सकता है, उसके राइट साइड पे कुछ भी आ सकता है. ठीक है, स्टार्ट करता है. Q naught as an initial state. The smallest string which possible from substring AB is A. We reach some intermediate state and then B. We reach to final state. ठीक है, बन गया सबसे smallest string के लिए. Now the next small, is it possible that B also accept that DFA? No. Now the next string is, अब हमें क्या देखना है, ए बी के लिए हमने बना दिया, ए बी की पोजीशन फिक्स कर दी. अब इसके लेफ्ट साइड पे कुछ भी आए हमें कोई फर्क नहीं पड़ता. इसके राइट हैंड साइड पे कुछ भी आए हमें कोई फर्क नहीं पड़ता। ठीक है, अब बचा सिर्फ एक Q1 का एक ट्रांजिशन, वो है आपका A। ठीक है, अगर मैं A इसी के ऊपर सेल्फ रूप में दे दूं तो हमारा DFA कंप्लीट हो जाएगा, बिकॉज इट हैज अ स्ट्रिंग एज AB। नाउ फॉर चेकिंग द DFA आई एम जस्ट टेकिंग अ रैंडम स्ट्रिंग AB AB A A B A। okay, so from A I reach Q1, then B I reach Q0, right? फिर AB कितना भी आए हमें सिर्फ चेक क्या करना था, AB आना चाहिए, उसके बाद ये कुछ भी आए एक्सेप्ट होना चाहिए, राइट? ठीक है, you can also check it by taking another random string in your mind. Okay, now the next is constructor DFA that accept a language or input alphabet AB that end with AB and start with AB। यहाँ पे दो कंडीशन दे रखी है, end with AB and start with AB। the minimum possible string is AB। ठीक है, इसमें is it dependent, this question is dependent that it exclude the AB or include the AB? I'm making that by excluding AB। okay, so the minimum possible string is AB AB, so we have to make a transition like A, फिर B देना है, फिर A देना है और फिर D देना है, और आपको फाइनल स्ट्रिंग पे आप पहुंच जाओगे B C D E। ओके, नाउ फॉर A, क्या ये इज इट पॉसिबल कि ये स्ट्रिंग आए? नहीं, बिकॉज द कंडीशन इज स्टार्ट विथ A। अगर ये कंडीशन आ जाती है जहां पे भी स्टार्ट की, तो इसमें एक स्टेट होती है, उसको बोलते हैं डेड स्टेट। डेड स्टेट मीन्स द ट्रांजिशन फॉर विच आवर कंडीशन इज फॉल्स। आफ्टर रीचिंग द डेड स्टेट, the transition not possible to go to the final state. If I'm going to reach a dead state, then there is no possibility to reach the final state. Okay, right? So is it possible that there should be like A? No. For this, the B transition is remaining, so the main important is to start with AB and with AB, and there is any combination of AB star possible. So there is any combination of AB star is possible. This is also A. If I am reaching E, then how to make a transition of A and E? So if there is A at the last state, तो हमें ये पता है कि अगर A आया लास्ट में तो हमें B पर ही फाइनल स्टेट पे आना है। ठीक है, A के बाद फाइनल स्टेट पे नहीं आना है, तो अगर A आ रहा है तो उसके बाद B आना जरूरी है फाइनल स्टेट को पहुंचने के लिए। ठीक है, सेम विथ अगर B आ रहा है और उसके बाद कोई और भी ट्रांजिशन पॉसिबल हुआ, मतलब B आया फिर B आया फिर B आया फिर B आया, तो हमें लास्ट में A भी चाहिए, तो हमें लास्ट में A भी चाहिए। ठीक है, मतलब अगर A आ रहा है लास्ट वाली स्टेट पे तो उसके बाद B आना जरूरी है, ये हमारी कंडीशन में गिवन है। तो हमने A आया तो हमने एक और B ट्रांजिशन दे दिया। अगर इसमें बोला है कि इसमें B आया है तो उसके बाद B एक A B का कॉम्बिनेशन आना जरूरी है, इसलिए हमने B को C स्टेट पे लाया, जिसके बाद हमें A और B का कॉम्बिनेशन पॉसिबल। नाउ यू कैन चेक इट बाय टेकिंग एन रैंडम स्ट्रिंग, इज इट रॉन्ग और करेक्ट। Now the last question of this module is to make a DFA that contains substring as 000. Substring means the minimum possible string is 000, taking an initial state, then 0, फिर B, then 0, फिर C, then 0, and then final state, right? Possible. Now the another string substring means 000 is a fixed path. स्टार्टिंग में 0 1 का कोई भी कॉम्बिनेशन आ सकता है, एंडिंग में 0 1 का कोई भी कॉम्बिनेशन आ सकता है। मीन्स स्टार्टिंग में 1 कितना भी हो सकता है, राइट? स्टार्टिंग में 1 कितना भी हो सकता है, और एंडिंग में 0 1 कुछ भी कॉम्बिनेशन आए हमें चलेगा। अब बात बचती है कि अगर बी के ऊपर 1 आ गया, अगर बी वाली स्टेट पे 1 आ गया, सपोज योर स्ट्रिंग इज लाइक 0 1 0 0 1 0, ठीक है, तो 1 फिर 0, फिर अगर 1 आता है तो उसके बाद हमें क्या चाहिए, 000, राइट, फॉर गोइंग टू द फाइनल स्टेट। तो अगर 1 आता है तो उसके बाद मुझे 000 चाहिए फाइनल स्टेट के पहुंचने के लिए, ठीक है। सेम हम ऐसे ही सेम सोचेंगे सी स्टेट के लिए कि हमारे पास है सपोज 1 0 0 1। अब इस अगर सी पे 1 आता है फिर मुझे क्या चाहिए, 000, मीन्स सी के बाद भी मुझे क्या चाहिए, 000, राइट। So this is the way you can write substring 000. So this is all about the DFA, basic terminology, and DFA, how to construct a DFA. If you want some more question on DFA, and if you have any doubt for this session, you can contact me on a Telegram. If you like my video, then subscribe the channel and hit the like. Thank you.